Hanover winters are frigid, with an average temperature of 22 degrees Fahrenheit. To heat its buildings and keep the campus comfortable, Dartmouth burns 3.7 million gallons of No. 6 fuel oil annually, equating to a release of over 65,000 metric tons of carbon into the atmosphere. If Dartmouth truly hopes to move forward, the college should switch to electric heating in order to reduce its reliance on fossil fuels and lower its carbon emissions. This switch would make Dartmouth a clean energy leader among universities and institutions in the U.S. Dartmouth's current heating infrastructure relies on high-pressure steam distribution from the central heating plant located behind the Newhamp and Toplift dormitories. The plant burns No. 6 fuel oil to heat water and convert it to steam. This steam goes through a set of turbines to co-generate 20% of the college's electricity before it is sent out to heat buildings on campus. The college constructed the existing steam distribution infrastructure nearly a century ago. As these pipes degrade over time, Dartmouth will have to pour money into bandaging these outdated pipes to repair costly leaks. On top of the costs incurred to repair the steam infrastructure, No. 6 fuel oil also levies a high cost on the environment. When compared to No. 2 fuel oil or liquefied natural gas, burning No. 6 fuel oil gives off higher amounts of sulfur dioxide, contributing to acid rain. In addition, No. 6 fuel oil releases significantly higher amounts of particulate matter and mercury, which can be detrimental to human health. The college must change its heating source from No. 6 fuel oil to electricity if it hopes to achieve a cleaner energy future. There are two types of electric heaters we recommend bringing to campus: electric resistance heaters and split pump heaters. Each would have a different application on campus, primarily depending on the specific building's age. Electric resistance heaters work in a similar way to the traditional radiators found in many of the older buildings around campus. However, instead of running steam through the apparatus to heat cast iron, electric resistance heaters run a current through a coil of wires made of highly resistant material. This highly resistant material heats up and warms the surrounding air at 99% efficiency. There are a few different types of electric resistance heaters. However, we recommend replacing the existing steam radiators with electric baseboard heaters in older buildings like Dartmouth Hall and Russell Sage Dormitory that do not have central air. The baseboard units would produce the same output as the radiators without the need for steam. Split heat pumps employ a slightly more complicated process that runs entirely on electricity at 250% efficiency in producing heat. The technology works like a refrigerator in reverse, using the heat from outside air to warm the inside of a building. There are two components to split heat pumps: the indoor and outdoor units. The outdoor unit extracts heat from the outside air, while the indoor unit spreads this heat throughout the building. This process would work even in frigid Hanover temperatures, as the cold refrigerant can absorb heat from outside air at temperatures well below freezing. We recommend a large split heat pump for the newer buildings like the East Wheelock dorms or Barry Library that have central air. Scaled up to a commercial size, a split heat pump could distribute hot air throughout these buildings through their air ducts. Within the next 2 decades, the college will need to replace its rapidly aging heating infrastructure. Switching to a hot water pipe distribution network or building a new plant would turn the entire campus into an active construction site and cost hundreds of millions of dollars. Meanwhile, replacing the current steam heating infrastructure with electric heating would be much less expensive, as its installation would only involve retrofitting to the existing buildings on campus. It's also important to acknowledge that if Dartmouth installs electric heaters, their operation will only be as clean as the fuel mix used to generate the electricity that powers them. Liberty Utilities, the local electricity utility, can provide a cleaner fuel mix than the exclusive use of No. 6 fuel oil currently burned in Dartmouth's cogeneration plant. We can also assume that Liberty Utilities will gradually transition towards a cleaner fuel mix. This is evidenced by their plans to build a solar farm in California that will generate 50 megawatts, meaning 25% of their total consumer electricity demand. Much like Liberty Utilities and other institutions across the nation, Dartmouth is committed to transitioning towards a cleaner fuel mix. The college announced in April 2017 that it plans to transition the campus heating system from No. 6 fuel oil to renewable sources by 2025. In order to obtain clean electricity for heating and other uses, the college should install more PV panels surrounding campus, import wind power, and get the rest of their electricity on the grid from Liberty Utilities. However, the existing steam heating infrastructure would not be compatible with Dartmouth's planned switch to renewable source heating. The primary benefits of electric heating are thus heavily weighted in the long term because they are contingent on Dartmouth further incorporating renewables. A potential issue with electric heating is that if there's a blackout, the heaters would stop working and the campus would go cold. To address this problem, the college would need to look into battery storage and backup generators that could run the electric heaters in the event of a blackout. Overall, Shifting to electric heating would show that Dartmouth is prepared to move towards a cleaner energy future, which should be one of the college's top priorities given that its power plant has been running on number 6 fuel oil for nearly a century.